Math 3 Classwork 1.4. So I'm going to go over to the answer section and just talk through the answers. With these first three problems, you are just plugging a number into the function where the x is located. So you can see with f of x equaling negative 2x, the negative 2x becomes negative 2 times the 6 that is in there. And then for number 2, you're taking the g function and substituting b squared into the x, so it becomes 2b squared plus 5. For number 3, you're plugging negative 1 into the h function. It has two x's, so both of those x's have to have negative 1 plugged in. The negative 1 in parentheses squared is negative 1 times another negative 1, so positive 1. And ultimately, we get 12. Now, the next three problems have a function inside of another function, and we call that function composition. Function composition is an operation between two functions, but one of them is substituted into the variable of the other function. So for f of g of x, I always start with the outer function and write down what that outer function is. F of x is negative 2x, so I write f of parentheses equals negative 2 times parentheses. Then I take the inside function, which is g in this case, and g is the function 2x plus 5. So that 2x plus 5 is going to substitute into where the variable x is of f of x. And you can see it right here, negative 2 times what was just x for f of x, now has inside of the x a 2x plus 5, and it substitutes and replaces the x that was for f. And then distribute the multiplication over the addition. Number 5, I'm actually going to start with plugging a number into g, the inner function, because this one is plugging a number in, whereas number 5 was just having a variable stay there. So I look to g is 2x plus 5. I substitute the x with the negative 1 that it says here, and I get a number. That number is now going to take over g of negative 1. It is the y value. But it becomes the input variable of h. So I look at h. H is x squared plus 3x minus 10. And I substitute the 3 into both of those x's, and I end up getting 8. Then number 6 goes back to the function composition with a variable in the middle. So in those situations, I start with the outer function, and I replace the inner function f of x with what f of x is. F of x is negative 2x. So I'm substituting in and replacing f of x with it. For h is x squared plus 3x minus 10. So everywhere I have that x, I substitute in negative 2x. And a reminder, this parentheses right here, that negative 2 and the x are all being squared. So it's negative 2x times another negative 2x to give me positive 4x squared. Now, the equations we are doing that are exponential right now will only have the same base. So for number 7, you have a 9 as a base to a power of 3x minus 1. On the other side, you also have the same base of 9 to the power of x plus 5. And because exponential functions are one-to-one, which we will see later in the class, I am allowed to just make the exponents equal to each other if those bases are the same. So just knock off the bases, and the exponents must equal each other. And then you need to bring the x's into one side of the equation. I did it by subtracting 1x to both sides, and then I added 1 to both sides to get equals 6. Divide by 2. In number 8, the bases are both exactly the same, so I set the exponents equal. So the exponent x squared must equal the exponent x plus 30. Now this is quadratic. Every time you have a quadratic equation, make sure you set one side equal to 0, and then factor if you can, and solve for each factor being equal to 0. So this factors to x minus 6 times x plus 5. So you set each individual factor equal to 0, and if x minus 6 equals 0, I add 6 to both sides to get 6 for one of my answers. If x plus 5 is equal to 0, then I subtract 5 from both sides to get negative 5 for my answer.